So now let's look at sets. So basically we're gonna do the same thing that we did like on a previous video of fractions. We're just gonna look at how to add, subtract, multiply, and divide sets. So basically I'm just gonna give you a little bit of an explanation of what is a set now. So basically a set is anything that can be represented with a root, any number that can be represented with a root. So as long as it has a root here, it can either be a square root, for example, also a cube root, a fourth root, a fifth root, or whatever root that it is. So this is actually a what a set. So as long as we have the root here. So basically now if you have a set like this, you can write it as an exponent. Let's say for example you have a cube root of a. Remember, any number always has a power of what? Of 1, if ever there is no exponent with it there. So if ever you want to write this as an exponent, you will do what? You will actually keep a there, but now the number of that is outside the root will divide with the exponent of the number that is inside the root. So basically outside the root we have 3 here, and then the exponent of the number inside the root is 1. So basically we're gonna have 1 here, and then this one will be divided by the 3 that is outside the root here. So it's going to be a to the power of 1 over 3. So of which is going to be the same. Let's say if we have the fourth root of, like, let's say a to the power of n minus 2. So basically what's going to happen is that now this number outside the square root will divide the exponent of the number that is inside. In this case, the exponent is n minus 2. That means we're going to drop a here, and then n minus 2 will be divided by 4. All of it will be divided by 4. So basically that is how you convert what? That is how you convert your set to an exponent. So now let's go straight to how to add, subtract, and multiply or divide the sets. So we're gonna start with first by what? By adding the sets. So let's say for example you can only add sets if ever what is inside the square root is the same. Let's say for example you have a square root of a plus a square root of a. That is only when you can do what? You can add your sets. To say now a square root of a plus square root of a will be equivalent to 2 square root of a. So you will basically treat your square root of a as a variable, like for example as if you have a plus a, which is going to be 2a. So but now be aware, if ever you had one of the root having a different coefficient to make it an unlike term, you can't add these terms now, because now the coefficients are not the same. And also if ever, let's say for example inside the root we are not actually having the same term, let's say this is a squared here, basically cannot add a square root of a with the square root of a squared, because they are not the same root. Actually they must be the same, like to say square root of a plus a square root of a, or maybe the coefficient must be a number here, but it must what is inside the square root must be the same. Let's say for example we have this one, square root of a plus 2 square root of a plus square root of a. So basically we're going to say 2 plus 1, which is going to be what? Which is going to be 3. We're just going to take this set as a normal a or b, or as a normal variable. So now let's make a practical example to say now, let's say for example we have what? We are given what? A square root of 8 plus a square root of 32. So if we are given something like this, so basically the first thing that we'll have to do, it will actually just to break what is inside the square root, so that we can be left with the same square roots. So here in this case we can write 8 as what? 8, we can write it as what? As 4 multiplied by 2. And also here 32, we can write it as what? As 16 multiplied by 2. Be aware now, when I leave or I just convert this one here, I make sure that one of the number that I multiply with is a perfect square, so that we know what we're going to be left with is going to be the same thing. So 4 is a perfect square in this case. It's multiplied by 2, so I'm also going to multiply a perfect square here, so that with 2, so that I can do what? I can have the roots to be the same. So in this case, I will just say, okay, we can separate them now, to say now when it's a product like this, you can write it like this. Let me just show you. Say the square root of 4 multiplied by square root of 2, so it's the same thing. And then you can say now you have a square root of 16 multiply by square root of 2. So basically this is the same thing. We're actually going to deal with it on multiplication, on how to multiply sets, but now you already know. So if you multiply the sets like this, basically you can multiply the numbers that are inside those sets. But now remember, the condition is that the number outside the set, it must be the same. In this case, we only have a square root, so that is applicable. So basically now we'll say now square root of 4 is the square root of 4. Square root of 4 will give us 2, and then we'll be left with what? With square root of 2, because it will give us a decimal number. And then now square root of 16 will be 4 into square root of 2. And then when we are here, what we can do now, we can do what? Now we can add the sets, to say now 2 plus 4 is equals to how much? Is equals to 16, because they have the same root, which is 2. So it's going to be 6 square root of 2. This is how you add what? You add your all your sets actually. So we're also going to do the same thing when you subtract your sets. So it's just the same thing. If, let's say, for example, the sign here was negative, so you're only going to subtract. Let's say now it was negative, then everything will be the same, but now we just have to do what? We just have to subtract. Okay, I just don't want to actually waste any time here. So basically, if ever there's a subtraction in between, you're just gonna do the very same thing, to say now you will expand, or maybe to make this number here inside to have the same number that will be left inside the square root as this number. So we divide this 4, to say now it can be written as what? As 4 times 2, and then this 32 can be written as 16 times 2. Remember, one of the numbers must be a perfect square, but that perfect square must not be the number that we want to be to leave left behind inside the square root. So we just simplify here. We can expand it to write it like this, then the answer will be like this. And then now when you subtract, you will just say 2 subtract 4, of which your answer will be what? Will be negative 2. Of which your answer will be negative 2 square root of 2. Okay, so basically that is how you do what? That is how you add and subtract your exponent. So now let's look at how to multiply and divide exponents. Let's say, for example, you have now the square root of a multiplied by square root of a. So basically, when you multiply your roots like this, if ever they have the same number, remember they must have the same number outside. So you're gonna say what? You're gonna say this is the square root of what? Of a multiplied by a, of which is going to be what? When you multiply the same base inside, you add the exponent, so it's 1 here, it's 1 here, so it's going to be square root of a squared. And then remember, there's a 2 outside here, so basically that 2 will divide with this 2 here will divide the exponent, so we're going to be left with what? We're going to be left with what? With a all to the power of 2 divided by 2, which will give us what? Which will give us a. So basically we can see now, we can apply to say now, if ever we have a law like this, to say if the square roots are the same like this, the answer will be a, because we have just proven it now. So when you multiply the same numbers inside the square root, the answer will just be a. Okay, let's say for example you say square root of 3 multiplied by square root of 3, So basically we normally know that the answer will be what? The answer will be 3. So let's now see if ever we do what? We divide to what? We divide the numbers that the sets. So let's say for example we have what? We have a square root of a square root of a divided by square root of a. So basically we're just gonna treat this thing as a normal thing to say now this is square root of a divided by square root of a. Okay, so it will be square root of a, and then remember when you divide, this is over 1. When you divide, you change to be multiplication, and then it will be 1 all over square root of a. And then now you can see now this a and this square root of a can cancel out, and it will be left with what? With 1. So basically every time when you see a division, you just try to change, swap it so that it can be multiplication, and then you can divide your things there. Let me not just go far with this one because it's just normal basics. Yeah, but then you will have to apply them. If ever you have values here, you can just put it in your calculator and then you get the value. Thank you very much.